Good morning. This is your Stats Sensei, Mr. Spensei, and this is Death Packet Unit 3B, Geometric Binomial Normal Distribution and Central Limit Theorem. So these will be questions number 1 through 10. Past records indicate that 15%, so we have a probability of 15% of the flights for a certain airline are delayed. Suppose flights are randomly selected one at a time from all flights. Assume each selection is independent of another. Which is the following is the probability that it'll take 5 selections to find one flight that is delayed. In other words, to find the first flight that is delayed, probability it'll take 5. So since we're looking for the first, I know this is going to be a geometric, and we're basically going 1, 2, 3, 4, 5. The first success is going to occur on the fifth one. We're circling a singular value. So this tells me it's a geomet PDF. All right. And really what that means is 1, 2, 3, 4, 5. 15% are delayed to find the first one that's delayed. So this is 15. This is delayed. And these are all not delayed. So technically I could write 85 all the way across and that would work. But we're going to use the calculator and make this a little bit faster. So second vars, geometric, PDF. Probability of a delay is 0.15. They want it to happen on the fifth one. And it's 0.0783. That's answer choice A. Once again, this could have been 0.85, 0.85 all the way across. So 0.85 to the 5 minus 1 or fourth power times 0.15. All right, the next one. A representative from a company that manufactures items for left-handed people will attend a large convention. The representative hopes to find a left-handed person at the convention to try out the items. The representative will select an attendee at random until a left-handed person is found. Assume each selection is independent of another. That's important. 10% of the convention attendees are left-handed. What's the probability the representative must select 4 to find 1? So in other words, we're going to go 1, 2, 3, 4. This will be the first one. The first one will be on the first one. So this makes this a geomet PDF and not left, not left, not left, and this one is left. This is 10%. This will be 0.9. So this is essentially going to be 0.9 to the 4 minus 1 or 3 times 0.1. Or going to the calculator, second vars, geometric, PDF, 0.1, x value is the 4 because it's the fourth person. Oh, but in this case, we wanted 0.9 to the third times 0.1 because not left, not left, not left, and then left. So 10% with 0.9 to the third. Well, that's not this one. That's not any of these. That's to the fourth. Oh, there it is, 10% and 0.9 to the third. The order is different, but nonetheless, it is the same value. All right, number 3. In a certain region, 10% of the homes have solar panels. A city official is investigating energy consumption for homes within the region. Each week, the city official selects a random sample of homes from the region. Let random variable y represent the number of homes selected at random from the region until a home that has solar panels is selected. The random variable y has a geometric distribution with a mean of 10. Which of the following is the best interpretation of the mean? Mean is the expected time number until we have our first success. So if we did this on average in the long run, over the long term, or if we did this over and over again, we would expect it to have to find 10 homes in order to find one that has the solar panels. Each week, the number of homes increases by 10. No. For a randomly selected week, it will take 10 homes before a home with a solar panel is selected. No, on average, it takes 10 homes, not on any particular week. The average number of homes per home is equal to 10. No, we don't. That has nothing to do with the question. Over many weeks, the average number of homes with solar panels is 10. No, we have to investigate to find 10 homes on average to find one with a panel. Over many weeks, so doing it over and over again, It takes 10 homes on average before a home with solar panels is selected. So our answer choice is E. Number 4, approximately 9% of the residents of a large city have seen a certain theater production that is currently playing in the city. So we have a probability of 0.09. A marketing researcher will randomly select residents until one is found who has seen the production. What is the expected number of, oh, that's the key word, expected number of residents the researcher will need to ask to find someone to find the first one who has seen the production. Well, the expected value for a geometric is 1 over p. So in this case, it'd be 1 over 0.09. So let's take that and see what happens. 1 divided by 0.09. We end up getting about 11.11. So our best answer choice is E, 1 over 0.09. The next one, the random variable k has a geometric distribution with a mean of 16. Which of the following is closest to the standard deviation? So that means I have to do some work. Well, remember, the expected value is 1 over p. So they're telling me 1 over p equals 16. So I need to solve for p. Well, 1 over p would equal 16 over 1, at which point I can go, oh, I'm dividing by 16. So let's do that, and then we can find out what p is. So 1 divided by 16, because basically 1 times 1 divided by 16, because that's what we're doing. P equals 1 times 1 divided by 16. So 1 over 16. That's my p-value, 0.0625. So p equals 0.0625, but they asked for the standard deviation. Well, the standard deviation of the geometric is 1 minus p over p. So in this case, the square root of that, the square root of 1 minus 0.0625 over 0.0625. So let's see what happens when we try that out. 1 minus the 0.0625. I got to take the square root of that. So I'm going to just raise it to the half power. Now I have to divide it by 0.0625. When I do that, I end up getting 15.49. So that's my answer for that one, is D. At a certain restaurant, 35% of the customer order the daily special each day. Oh, so p-value of 0.35. Assume that each day that they arrive randomly and order independently. Let the random variable x represent the number of orders placed until the first daily special is ordered. The distribution of x is geometric and has an expected value of 2.86. Which of the following is the best interpretation of the expected value? Again, on average, we expect 2.86 to order the daily special. So over many days, the average number of customers is approximately, maybe. Well, let's back up. Each day, 3 customers will order. No, because it's never specific. All right. Over many days, so the average number of customer order the daily is approximately 2.86. I like approximately. I like over many days. This is looking pretty good. I like B kind of a lot. Let's keep going on and see if there's anything better. Over many days, it takes about 2.86 orders on average to be placed until the first daily special is ordered. Yes, much better. All right. On average, we have to do 2.86 to find the first one because it's the geometric. So we're talking about the first, and this one was a binomial. It wasn't talking about the first. Number 7, in a certain board game, a player rolls 2 fair 6-sided die until the player rolls doubles, where the value of each die is the same. The probability of rolling doubles with 1 roll or of 2 fair 6 dice is 1/6. What's the probability that take 3 rolls until the player rolls doubles? Well, that means I'm going 1, 2, 3. So this is doubles on this one. So that's 1/6. This is not doubles, and this is not doubles. Well, remember, if it's 1/6 is doubles, 1 minus 1/6 would be not doubles. So this is 1 minus 1/6, and this is also 1 minus 1/6. And 1 minus 1/6 is just 5/6. So this is 5/6 times 5/6 times 1/6. Well, that's 5/6 squared times 1/6. Well, 5/6 squared times 1/6, that's answer choice D. Number 8, a recent report indicated that 22%, so this is our P, we got a probability of 22% of households in a certain community speak a language other than English at home. A reporter will randomly select a household from the community until the first household that speaks a language other than English at home is selected. Let random variable Q represent the number of attempts needed until the first household that speaks a language other than English is selected. The random variable Q has a geometric distribution with P equals 0.22. Which of the following is closest to the variance? All right, so here we go. First off, they don't give us the variance, but they give us the standard deviation formula. So the standard deviation is 1 minus P over P. Well, if I square that, I get the variance. Well, when I square that, that becomes this the standard that my variance. There it is. My square root sign comes off, but this P gets raised to the second power. So that becomes my formula. So which point I have 1 minus 0.22 over 0.22 squared. So 1 minus 0.22, that's 0.78, divided by 0.22 squared. So I end up getting about 16.1157. So my best answer choice is E. Again, this is 0.78 over 0.22 squared. All right, moving on to number 9. The transaction history of an electronic goods store indicates that 21% of customers purchase the extended warranty when they buy an eligible item. Suppose customers who buy items are chosen at random, one at a time, until one is found who purchased the extended warranty. Oh, we're going to continue into the first. Let the random variable X represent the number of customers it takes to find the first one who purchased the extended warranty. Assume customers' decisions on whether to purchase the extended warranty are independent. Which of the following is closest to the probability that X is greater than 3? That is, the probability it takes more than 3 customers to buy an eligible item. All right, so we know we're looking for the first, so that means it's a geometric. So 1, 2, geometrics always start at 1. But this is going to infinity. So that means I'm circling these values right here. So that means I'm going to have to go to the summation part of the calculator. So, and it also means I'm doing a 1 minus. So we're going to go 1 minus the summation. I'll put this in brackets. Now we don't have to write all this down, but I'm hoping it'll help you. Is 1 minus P to the X minus 1 times P. So in our case, our lowest value is going to be 1. Our highest value is going to be 3. So let's try that out in the calculator. So clear 1 minus, you know what? I'm going to write this all the way out just because I think you need to see it. So 1 minus bracket P 1 minus 0.21 to the first power, or 1 minus 1, times the 0.21 plus plus 1 minus 0.21 to the 3 minus 1 because it needs to be greater than 3. So 4, 5, and 6 times the 0.21. So here we go. 1 minus math button, summation, press X equals our lowest value we have is right here at 1. Our highest value we have is 3. Second vars, geometric PDF. P we said was 0.21. X value, remember, whenever you have summation, you have to use the X. And we end up getting 0.493. So our answer choice to this question is C. .493. Suppose a manufacturer knows that 20% of the circuit boards coming off the assembly line have a minor defect. If an inspector keeps inspecting boards until he comes upon one with a defect, what's the probability have to inspect at most 3 boards? All right. So basically 20%. So we have a P of 0.20. He's going to keep inspecting until he comes upon one. So that means he's going to inspect until he finds the first one. So we want to know the probability that he has to do at most 3. 1, 2, 3, 4. But we said at most 3. So we're looking for these values right here. So we want the probability that X is less than or equal to 3. But I have more than one value, so this is going to be a summation. So in other words, it's going to be a summation of a geometric, but infinity is not circled, so I don't have to do the 1 minus like I had to above. So in this case, I'm going to just press the math button, drop down to summation, press X, and my lowest value is 1. My highest value is 3. And second vars, geometric PDF. My probability of a defect was 0.20. So I need to change that to 0.20. The X value, if we're doing summation, is always going to be X. And I end up getting 0.488, which happens to be answer choice C. All right. This concludes our first video. Hope it helps, and we'll see you on the next one. Thank you.